Volcanoes versus climate change. Who's really responsible for this island? In 2018, an Indonesian volcano rumbled back to life after 300 years of slumber, spewing smoke and ash into the sky and sending terrified residents fleeing for higher ground. Mount Pinatubo had other plans though, or rather Mother Nature did. After all, it's not every day that volcanoes interrupt the global climate. But this seemingly random eruption was actually a carefully orchestrated part of our planet's natural climate system, one that we are only just beginning to understand. So join us as we explore the surprising link between volcanoes and climate change. A small price to pay for paradise. It's no secret that living on an island has its perks. Just ask any beach lover or self-proclaimed castaway. That's why it's hardly surprising that more than half of the world's population lives within 60 miles of a coast. Of course, you can also swap out the word lives for exists because islands are everywhere. In fact, there are at least 2 million dotted across the globe, ranging from well-known hotspots like Hawaii to more obscure locales like the remote Prince of Wales Island in Canada's Arctic archipelago, which is home to less than 100 people. Now, even if some of these islands might seem like a little bit of a stretch when it comes to paradise status, they're still home to a whole host of wildlife and plant species. And we know what you're thinking. If they're so great, why haven't we colonized them all already? Well, many of the most uninhabitable islands are actually situated in places where the ocean water is too cold to comfortably bathe in or too stormy to reliably sail through. Take Iceland, which, despite its name, is basically uninhabitable. Despite having the word Iceland in its name, thanks to its perpetually chilly temperatures, glaciers, and volcanoes. But perhaps the biggest buzzkill of all is Indonesia's Krakatoa Island, made infamous by the massive 1883 eruption of Krakatoa volcano, though it wasn't the first nor the last time the volcano would erupt. So aside from creating one heck of a natural barrier, these islands don't exactly offer up the most prime real estate. However, there's something else to consider. Since 1990, sea levels have risen by nearly 3 inches, and scientists predict that that number could double or even triple by the year 2100. Now 3 inches doesn't sound like much, but even a small rise can submerge entire islands and displace thousands of people. And it's not just rising seawaters that pose a risk either. Many low-lying islands are also contending with soil erosion caused by increasingly extreme storms and more prolonged droughts. But before you start worrying that you'll be losing your tropical getaway anytime soon, it's worth taking stock of who or what is really responsible for these changes. Enter the climate change culprits, aka the villains of the piece. Most people point the finger at human activities like burning fossil fuels. After all, it's well documented that carbon dioxide and other greenhouse gases are warming the atmosphere and oceans at a rate faster than ever before. And sure enough, scientists estimate that human activity is responsible for about 3/4 of the current sea level rise. But that leaves about a quarter that scientists are struggling to explain. And while we may be able to blame ourselves for a lot of the world's problems, this isn't one of them. We're going to need some serious help explaining this one away. Time to bring in the cavalry. Smoking out the truth. When it comes to solving mysteries, it always helps to have a good detective on the case. And in this scenario, that means turning to geologists and oceanographers. To figure out what's behind those missing pieces of the puzzle, they turn to deep-sea sediments, tree rings, and ice cores, searching for clues that could shed light on how the climate has changed in the past. And what they found was pretty shocking. It turns out that sea level rise isn't anything new. In fact, over the past 6,000 years, it's gone up and down as many as 14 times. That's right. Our planet's got a bit of a history of fluctuating sea levels, and the culprits behind those changes aren't what you'd expect. Volcanoes, glaciers, and even tiny plankton all play their part in the Earth's natural climate system. But let's take a closer look at the ringleaders. When a volcano erupts, it releases tons of materials into the air, including sulfur dioxide gas. Unlike carbon dioxide, sulfur dioxide reflects sunlight and clouds, helping to block the sun's rays and keep the planet cool. Some compounds stick around for months or even years, creating a haze so thick that it can be seen from space. And while it might sound like a scene straight out of a sci-fi movie, this actually happened in the Philippines in 1991, when Mount Pinatubo erupted, spewing 20 million tons of sulfur dioxide into the atmosphere. That eruption was so massive that it actually led to a slight global cooling effect, dropping temperatures by about 2 degrees Fahrenheit according to NOAA. And yes, that's the same Mount Pinatubo that recently woke up after 300 years. Of course, volcanic eruptions aren't the only thing that can trigger these changes. Glaciers, which are formed by the accumulation of snow and ice over time, can also have a major impact on sea levels. As they melt, they release fresh water into the ocean, which can reduce the salinity and disrupt ocean currents. That disruption can affect the amount of heat and moisture the ocean can hold, leading to shifts in precipitation patterns and storm intensity. Okay, so we've established that volcanoes and glaciers can both contribute to rising sea levels, but what about those pesky plankton? Well, they might be small, but they make up for it in their big impact on the climate. Tiny single-celled organisms called foraminifera live in the ocean and form shells made of calcium carbonate. They absorb carbon dioxide from the atmosphere, and when they die, their shells sink to the bottom of the ocean, locking the carbon inside. But warmer ocean temperatures can make it harder for these organisms to form their shells, meaning less carbon is stored away, and more is left in the atmosphere to trap heat, and potentially lead to rising sea levels. As you can see, there are a lot of moving parts when it comes to our planet's climate system, so next time someone points the finger at you for leaving your tropical island home in ruins, you'll know who to blame instead. A rocky start. Now we know that humans aren't solely responsible for rising sea levels, but are we totally off the hook? Unfortunately, probably not. While natural fluctuations in sea level are nothing new, the current rate of change is unprecedented in human history, and as we mentioned earlier, human activity accounts for roughly 3/4 of the observed sea level rise since 1990. Even if we took all the carbon-emitting humans on a worldwide staycation, we wouldn't escape the consequences of our past behavior entirely. There's a lot of stored carbon in our lower atmosphere and oceans that could continue to trap heat for centuries or even millennia. What's more, volcanic eruptions and glacier melting aren't necessarily going to slow down anytime soon. Take Mount Vesuvius, for example, which experts predict will erupt again sometime in the next 3,000 years, and while that might sound like a distant threat, it's worth noting that the most densely populated areas are located along coastlines, putting millions of people at risk. So what does this all mean for us Earth dwellers? Aside from giving us yet another reason to stay vigilant about climate change, this discovery gives us a rare glimpse into the complex web of factors that influence our planet's climate. And by unraveling these connections, we gain a deeper understanding of the forces that shape our world. So while we may not be able to blame ourselves for all the changes we're seeing, we can take comfort in knowing that every problem has a solution. All it takes is a little bit of knowledge, creativity, and ingenuity. For instance, researchers are exploring ways to capture carbon dioxide emissions from the air and store them away safely. Meanwhile, others are developing innovative methods for desalination, which could provide fresh water for coastal communities affected by rising sea levels. By investing in research and development, supporting sustainable practices, and raising awareness about the challenges we face, we can all play a part in creating a better future for ourselves and the generations to come. And hey, who knows? Maybe someday we'll even find a way to put those pesky volcanoes to work for us instead of the other way around. Now check out why polar bears are white, or watch this video instead.